All right, so object-based image analysis for 5G telecommunications. The first question you might ask is what is 5G? And 5G is the 5th generation of cellular networks. It's set to be as much as 100 times faster than the current 4th generation cellular technology, with speeds of up to 100 gigabits per second. It also will be fixing bandwidth issues. Object-based image analysis has traditionally used satellite imagery. Landinfo primarily uses aerial photography, which is, of course, of higher resolution. And at one point, I was going to say that object-based image analysis isn't exactly, it's pretty straightforward. It's not rocket science. Then I realized that when we use satellite imagery, it actually is rocket science. So what we're doing is better than rocket science. Everybody, I guess we're rapidly running out of time, so I'll just do my best here. So earlier this year, Landinfo's work was featured in POB magazine, Point of Beginning magazine. And I reprinted the article for you, and I've got them. So please get a hold of me. And actually, there are a couple flyers I can give you that'll give you a lot of information here. But I'd like to read directly from this for a moment. It says, to achieve the forecasted wireless speeds, telecom companies will need a notably denser array of small antennas and generally need to maintain line of sight for the transmission to work. To help resolve this critical challenge, multiple U.S. telecom companies have tasked Landinfo with creating customized mapping of selected areas of interest. In particular, they requested 3D models of AOIs that would include layered views of 3D building footprints, classified land cover, and classified tree contours and their heights. So that kind of is a synopsis of it. And POB magazine reprints. I've got about 20 of those, so just look me up. For this work, we created NDSMs. That's normalized DSMs. A DTM shows height above sea level. A DSM, or digital surface model, adds height to the above-ground object or obstruction, such as rooftops or tree canopy. A normalized DSM, an NDSM, shows the difference. And we use e-cognition software. We do this with bridges, and as bridges can be obstacles, and for all sorts of other obstacle layers. In addition to bridges, we create specialized layers such as utility poles, building material types, sound wall barriers, deciduous versus coniferous tree classifications, tree crowns and estimated trunk locations, etc. I've got a number of slides showing different cities that we covered: Philadelphia, 1 meter raster clutter, 1 meter raster clutter of New Orleans, Chicago, buildings, water and tree layers for Houston. And for across all the cities, we created about 40 different layers of classes. In Las Vegas, got a slide that shows the tallest buildings, and obviously that's important for placement of sensors. In addition to building footprints, we create a layer that shows top prints for more precise data. We end up with a really realistic view that the companies are able to use. Showing rooftop detail. We were able to extract sound wall barriers, which are important for, if if you don't want to hear all the noise from traffic, but they create a real obstruction for telco. So we were able to capture that information from the aerials and render that for the companies to be able to do proper placement of the sensors. Bridge thickness is captured, so that's the fourth dimension. In addition to getting the ground Z value and the height of the bridge, you also get bridge thickness, which is important so they can either shoot above or below the bridge for telecommunications. Construction materials make a difference, so we capture those layers, different construction materials used for different types of buildings. Types of trees make a difference. Tree count, tree density. And this year, Inc. magazine named Landinfo as one of the fastest growing small companies in America, which is a big deal for us because we're actually a very small company. We were also named to the Denver Fast 50. And this was all as a result of the work that we've done for the 5G rollout. Again, sorry for the technical difficulties. I'm Jeff Forbes. Please look me up. I'd love to give you a copy of this. Thanks again.